LEDS Global Partnership and specifically the Asia LEDS Partnership and the Benefits Working Group, and I'm very happy that two colleagues of ours from UNDP and NREL have joined us today. For your participation options, please keep in mind that there are two options for audio, so you can listen through your computer or by telephone, and you will be muted throughout. If you have any questions or want to raise a point, please go ahead and write something in the little chat box that you can see on the right-hand side. And we will also be answering questions after the presentation, so go ahead and send us questions during the webinar already. If you have any technical difficulties, there is a help desk that you can call, but I hope that everything goes smoothly. So today we have presenters from NREL and UNDP helping me out. So Francisco from NREL, from the National Renewable Energy Laboratory, will be helping us with the webinar. He's an energy analyst at NREL in the US, and he has working experience with a specific tool that he will be presenting today that looks at jobs and economic development impacts. It's the so-called JEDI tool. And Francisco has degrees in electrical engineering and in energy management, so very much also focused on technical aspects in the energy sector as well. We also have with us James Vener, who has spent a couple of years working with the UN in different areas, mainly climate finance and sustainable clean energy market development. He works from the New York office. He works mainly also on nationally determined contributions, on nationally appropriate mitigation actions, on monitoring, reporting and verification, and in different countries with institutional support. And he also has a technical background. He's worked as an environmental engineer, and he has degrees in engineering and a professional engineering certification as well in the US. And just to myself, about myself, I am Natalie. I co-chair the Benefits Working Group of the LEDS-GP. I'll say a few things about that in a minute. And my work mainly focuses on integrating sustainable development and climate change targets and planning in low emission pathways. So I work at the Energy Research Center of the Netherlands, ECN, and I work there also mainly on NAMAs and NDCs, and I worked on gender mainstreaming in Southeast Asia before. All right, so about today's webinar, I'm going to give a quick introduction on the LEDS-GP and the general topic, and then I will hand over to Francisco, who will tell us about the iJEDI model and using some examples from the region as well. And then James will tell us about the Sustainable Development Tool that UNDP has developed. And we will have some time as well for questions and answers, so please do go ahead and send us any questions that you might have. It would be helpful if you already indicate if there's a specific person that you'd like to answer that question. So quickly on what the LEDS-GP is. It's a big network of over 160 countries and organizations, a lot of practitioners and policymakers from all over the world. And what the LEDS-GP does, it focuses on low emission development strategies. So what it does, it facilitates peer learning and technical cooperation and information exchange to support low emission development strategies. So it has a focus on developing countries and regions, and it is a big network of peers that brings together support programs and helps policy processes and builds capacity as well. And in the LEDS-GP, there are 3 regional platforms: the Africa platform, the Latin American Caribbean platform, and the Asia platform. And the Asia LEDS Partnership is the platform that is hosting this webinar today. There are also a voluntary regional network of different individuals and organizations, and they focus on the Asia and Pacific region. And there they focus very much on supporting economic progress that also reduces greenhouse gas emissions, and they support the countries there in their green growth practices. They facilitate enhanced collaboration and learning, identify different tools, and foster capacity building and lessons learned sharing to strengthen the support for low emission development strategies across Asia. The LEDS-GP also has 6 technical working groups, so for instance energy and finance, and one of the working groups is the benefits working group, which I co-chair. So our objective is to align sustainable development and climate change planning and strategies more explicitly. So we look at social, economic and environmental impacts beyond greenhouse gas emission reduction and how to sort of put the two together. So we focus very much on the D in LEDS basically. And what we do is we develop outreach briefs and trainings and toolkits and case studies and webinars such as this one to identify benefits of low emission measures and development across different sectors and also to communicate them. So what are we looking at today? We're looking at economic impacts. Now this is very important because economic development it's a priority in most countries, I would say, and in developing countries even more so than reducing emissions, which is also something that we can see from a lot of the nationally determined contributions from the Asia region. And the goal here is really to think about how to align economic development with climate change targets. So how do you as a country, as policymakers and practitioners, how do you choose low emission pathways that lead to green growth and can create jobs, but also combat climate change and can adapt to impacts from climate change? And the good news is that a transition to a low carbon and environmentally sustainable economy can also be a driver of job creation, of upgrading jobs, of increasing skills, and of reducing poverty if it's done in the right way. And at the same time, climate change poses major risks to economic prosperity in many countries, and it is felt especially in the Asia and Pacific region already. So uncontrolled climate impacts can cause damage to sectors, to companies, to industries, to infrastructure. It can destroy jobs and also livelihoods. So there is a very negative effect from climate change that needs to be mitigated in itself. And at the same time, there are big productivity gains to be held if we switch to a greener economy. So if we choose a pathway that does not encroach on countries' desire to develop economically, but just steers this development into a greener and climate resilient path that is more sustainable long term. So developments in green energy and resource efficiency, for instance, they can have a very positive impact on employment. And such developments can actually translate into what ILO estimates to up to 15 to 60 million additional jobs by 2030 globally. And while this job creation potential, it does outweigh the risks of job losses through climate change, and there can be overall positive labor market outcomes, but what is very important is to make sure that this transition is what we call just and fair. So this just transition for all means that we find responses to climate change that also maximize the opportunities for decent work creation that ensures social justice and social protection, so that that is the idea of leaving no one behind. That is something that is important to keep in mind in this context. And I've added a little figure here that I've taken from one of our outreach briefs, which you can find online, that was written by the International Labour Organization, that just has a look at, in the energy sector, how many jobs can be created from switching to different renewable energies. So you can see there are quite a lot of opportunities here if we choose the right pathway. So that just shortly from my side as an introduction, and what I'd like to do now is switch to Francisco so that he can tell us more about the Jobs and Economic Development Impact Tool, which is very nicely abbreviated as JEDI, and this is now the international version, so that would be iJEDI. Francisco, the floor is yours.
Thank you, Natalie. And good morning to everyone, and afternoon and evening. Yeah, at Vener, we've been developing the Jobs and Economic Development Impact Tool since 2004, and very recently we added an international version. I'm going to start talking about the JEDI tool in general, and then we'll see more specifically what the international version looks like. If we can go to the next slide. So JEDI stands for Jobs and Economic Development Impact Tool, and sorry, what it does is to estimate the economic impact of building and operating power generation plants in general. Most of our models deal with renewable energy generation. But we also have models for fossil fuel plants, for building transmission lines, and also biofuel plants. The economic impacts that the model measures are numbers of jobs, earnings that workers get through those jobs created by the generation plants, the total economic output, and the contribution to GDP from those projects that we're modeling to the region of analysis. Next slide. In very simple terms, what the tool does is to, starting from the nominal capacity of the generation plant or plants that we're looking at, it first estimates the direct impacts, which we also call on-site impacts, from these projects. And these direct impacts basically mean all the direct investment that the entity that builds the project makes. For example, the labor that the, say, developer pays to the workers who build, actually lay the foundations for the plant, install the panels, etc. So those are the direct impacts. Also, when you buy the panels, that's a direct impact. And we do that by looking at different reports that tells us how much do developers need to spend to build, for example, a PV plant. Then we use the input-output model to transform those direct impacts into, well, not transform, to estimate the impacts to the economy as a whole from those direct impacts. And we're going to see a little bit more about that in the next few slides. So if we can advance to the next slide. So I said that we start by estimating direct impacts. What are direct impacts? So in the example of a car manufacturer, the direct impacts are those that are paid for directly by the manufacturer. For example, the manufacturer will pay directly to the workers in the plant. Also, the manufacturer may need bolts and other supplies such as tires and headlights that the manufacturer buys from suppliers in the supply chain. So all those all those supplies and labor that the manufacturer pays directly for are direct impacts. If we go to the next slide, then we have indirect impacts, which are those these other layer of material, supplies, and labor that are needed to supply everything that was bought in the direct impact layer. For example, the bolt manufacturer will need an accountant to do its taxes. That will be an indirect impact from the perspective of the car manufacturer. Also, the tire maker will need chemicals to produce the rubber. That also will be an indirect impact. And of course, all these other manufacturers will need workers, will need to pay workers, which will also fall into the indirect impact category, again, from the perspective of the car manufacturer. And then finally, we have induced impacts, if we go to the next slide, which which are produced by the money that the workers at any level, indirect or direct, spend on the economy as a whole. For example, workers may buy food, which in turn will impact the agricultural sector of an economy, or they may go on vacation, and all those things that the workers pay for with their salaries. Those are considered indirect impact. Next slide. Indirect impacts, I meant. So how, again, this is a more detailed diagram of what the model does. On the left side, we see a stimulus, an economic activity, which in this case will be, for example, a PV plant, the construction of a PV plant. So we start by the model. The first thing it does is to estimate what is the direct impact. And so as you can see, we have a simplified economy on the left side under direct impact. And what that means is that this economy has 5 sectors: agricultural, construction, manufacturing, education, and tourism. And the stimulus is impacting 2 of those sectors, the construction and manufacturing sectors, directly. However, as I was mentioning before, there are other impacts beyond the direct impacts. And we use the input-output model to estimate those other impacts. And so the effect happens to be that in this example, all the 5 sectors of the simplified economy are affected by the economic activity that we're analyzing. For example, the workers may buy food, and that's an effect on the agricultural sector. You also need engineers to build the plant. So there's an impact on education as well. Another way of looking at the effects of an economic activity of building a PV plant is, what does the rest of the economy need to do to support that economic activity? Next slide. So as I was saying, the National Renewable Energy Laboratory, or NREL, has been developing the JEDI model since 2004. We average 3,000 downloads per year, so it's a very popular tool. We have identified 70 public studies that have used the tool between 2004 and 2012. 12 of those studies were published in 5 different peer-reviewed journals. And we have 15 Excel-based versions that work for the US. Those versions, even though they were designed to work for the US, they can be modified, and in fact they have been modified. We have an example. The government utility in Mexico, CFE, downloaded one of our models and modified it, so then now it works for Mexico. We also have a web-based version. This is for PV projects in the US. And finally, we recently developed the international version. Next slide. So the international version works for 4 technologies. As I said, for the US, we have 16 models, and they work for offshore wind, all types of wind, basically, PV, biomass, fossil fuels, etc. For the international version, it works for solar PV plants, biomass, wind, and geothermal. And out of the box, it works for 5 countries: South Africa, Colombia, Mexico, the Philippines, and Zambia. So this is, as I said, if you download the model, you can start using it right away to run analysis for these 4 technologies in these 5 countries. However, the the tool is designed to allow the user to enter custom regions. If you have the right data, you can use this tool to analyze your projects for any country and any region, actually, even at the subnational level. Next slide. This is a screenshot of the interface. As I mentioned, most of our models are based on Excel. This one is as well. And at the top, you can see the three most basic inputs. The country of the project, where the country where the project you're analyzing is, the size in megawatts of the project. This is in megawatts because the tool, as it is now, is calibrated to work with utility scale projects. But as I mentioned, and I want to emphasize this, the tool can be modified to suit almost anyone's needs. And then the dollar year in which you want to express the results in. And so when you select, when you input those three input variables, the model will automatically populate the costs, installation costs that you see below. This is just part of the interface. There are many other costs that you can enter. If you have better information, you can overwrite those default values. So the tool also allows the user to, for example, even if you're working in a country that's one of the default countries in the tool, you can update installation costs as they change, and we know that they change quickly, pretty fast, even or particularly for PV solar. The tool also has a help file that you can access, actually a help sheet you can access if you click on the question mark on the top. If we can go to the next slide. So the tool is designed to be used by people who may not have very sophisticated knowledge of the region they're analyzing, as long as it is on one of these 5 countries. But more advanced users can customize the tool and use it for their own countries. And if they have more accurate data, the tool will allow them to use that accurate data. I have this example. This is an analysis I participated in, and we looked at the economic impacts of developing offshore wind projects in the U.S. We divided the U.S. in 4 areas, and this is the example of the Gulf Coast area. You can see the map of the states that were considered in this study. And just very quickly, this was a rather complex analysis that we did. We considered 3 different deployment scenarios, one in which there was going to be very low growth in offshore wind deployment in the United States, moderate scenario, and then a high deployment scenarios. And those 3 scenarios change the input variables that we use to run our analysis. And then we run analysis for each of the years between 2020 and 2030. So it was an analysis done on several different dimensions. The growth in deployment, that was one dimension, and then in time, how things will change as the market grew, how quickly it was going to grow. One thing I mentioned very early is that the analyses are done for a certain region. So if you're importing labor or equipment, the money that goes outside the region is not counted towards economic impacts because we're only looking at a certain region, most typically a country for the international version. For the U.S. versions, we look at the state level, effects at the state level or at the national level. So if we can go to the next slide. So these are some of the results we got from those that study, the Offshore Wind study. This is just looking at the Gulf region. And as we can see, the tool can, I said at the beginning, can provide results about number of jobs created, contribution to the GDP, total economic outputs, and income. Here I'm just focusing on jobs. And the tool provides results for economic impacts in two phases. One is during construction, and the other one is operations and maintenance. Construction typically is a one-time impact on the economy, but then operations and maintenance, those impacts last for the duration for the lifetime of the project that you're analyzing, and so that's why we separate the two typically. We also consider direct, indirect, and induced effects. In this case, we're calling them on-site impacts. If you see almost at the top of the table, then we also have supply chain impacts. And then towards the bottom within the construction section, we have induced impacts. And similarly for operations and maintenance, we have on-site, supply chain, and induced impacts. And on the right-hand side, this is a graph that we produced using the results that we got, and see that we start this is the moderate scenario. We started with 5,000, a little over 5,000 full-time equivalent jobs for the region, and it grows up all the way to, I think it's like 23,000 jobs. And so the benefit of the tool, one of the benefits is to show that you're going to have a cost of developing all this technology to fight climate change. There are other benefits, including jobs that will be created in the region that you're looking at. And that's the end of my presentation. So I think we're going to have a question and answer session afterward. If you have questions, you can contact me. My email address is on the screen. And you can also go directly to the JEDI website. Thanks.
Thank you, Francisco. Just to let everybody know, we will also make these presentations available online, so you can have a look at them as well and also find the contact details again. James, can I hand over to you, and then we'll dive into a Q&A session where we can also maybe talk about some more examples from Asia and look at all of your questions. James, go ahead.
Terrific. Thank you, Natalie. Good morning, also from the U.S. here. Thank you for letting me participate in this very interesting discussion. I work for UNDP for the unit that focuses on climate change and disaster risk reduction, specifically for a program called Low Emission Capacity Building, or LECB. And what we do is we work with 25 partner countries to help them be put on to put themselves on a low carbon emission trajectory for economic growth. So very much aligned with what the LEDS GP is doing. I was asked to speak around 15 minutes on a presentation of a UNDP tool called the Sustainable Development Tool, or ST tool. And what it does is informs policymakers and project developers on how to determine sustainable development or co-benefit impacts of proposed initiatives. So this includes economic impacts. And this could be useful in the context of if there are different policy options that are being considered and evaluated. We're still on the first slide, that's fine. Then you can kind of decide which one can, for example, provide more jobs for the budget dollar. I have relatively little time to do this presentation, so I'll be kind of broad, and I'm glad to kind of go into more detail in the Q&A section, and also I'm providing my contact information if one-on-one feedback would be useful as well. So I'll begin by discussing how the Paris Agreement addresses sustainable development and carbon accounting or data management systems, because this is very much useful in terms of what the SD tool kind of puts in place, and we want to make sure that the SD tool related systems communicate and are collaborative with these national and global systems. Then I'll kind of describe the SD tool, and I'll follow up by providing a practical example of the way we've used the tool in Sri Lanka. So this is the second slide. I'll just say generally that the Paris Agreement went into force in November. 115 parties have ratified it, and it spells out that each party is to communicate a nationally determined contribution, or NDC, which is supposed to address emission reduction targets, say basically what the country is going to do to reduce greenhouse gas emissions. And 111 parties have so far submitted their first NDCs. So the Paris Agreement is very much at the core of what we try to do globally for climate change mitigation. It's very much a statement of political ambition, and post-Paris, what UNDP is trying to do is make sure that these ambitious goals and targets are translated into concrete national actions. So why is UNDP qualified to do this? It's a big part of what we do. We help countries to develop low-emission development strategies, help improve greenhouse gas inventories, develop these mitigation actions called NAMAs, and we work closely with the Green Climate Fund and the Global Environment Facility to help develop these types of projects. Next slide, please. Oh, and I'll just say we've also had a wonderful opportunity to work extensively with ICLEI, LEDS, and NREL in the past. So in the next slide, I'll just go through this very quickly in the interest of time. Basically, UNDP has 5 parallel and complementary streams of work to support the Paris Agreement. We provide technical and financial support for mitigation adaptation projects, improving data management systems and transparency, reaching out to the private sector to try to scale up investment is a big part of what we do. And increasingly, everything is kind of going under the umbrella of ensuring that countries are able to implement the NDCs when they get finalized. Next slide, please. So this kind of shows that there really is a big focus on sustainable development in the Paris Agreement. Here are a few mentions of it. You can see that the emphasis really shows that the new Paris Agreement regime focuses on sustainable development in the context of carbon accounting. It mentions double counting, avoiding double counting in several places, transparency, ensuring environmental integrity, and there's a big emphasis on making sure that emphasizing sustainable development in the context of ITMOs, or internationally transfer mitigation options, which are basically tradable carbon assets. So they want to make sure this future market system is done in a sustainable and equitable fashion. Next slide, please. So there are specific aspects that are required through the Paris Agreement for all parties that ratify it. Countries are required to submit national inventory reports for tracking progress of greenhouse gas emissions towards a 2-degree Celsius goal. All countries must track progress towards individual achievement of their NDCs. And for many NDCs, there is specific reference to Sustainable Development Goals, or SDGs. And I'll just say, one of the main uses of the SD tool is to help countries to develop, to select SD indicators and systems for tracking this sort of data for NAMAs and other sorts of climate change mitigation projects. So it's really important to keep tabs on where we are with the global climate change negotiations, because future decisions on the transparency framework, on the way different types of NDCs are going to be represented in carbon accounting, it's going to possibly have a trickle-down effect. And the types of carbon accounting systems that are put in place, for example, through the SD tool, should be able to share data with these national and global systems. Next slide, please. So now I'll kind of go into specifically the UNDP Sustainable Development Tool. It was designed for NAMA developers and policymakers to evaluate sustainable development indicators. And specific to the discussion today, things like economic indicators are typically of the most use to a lot of countries. This can include poverty reduction, jobs creation, economic growth, quality of life. And I'll just say that the SD tool has so far been used in the application of 7 NAMAs, and I'll go into a very brief description on what a NAMA is coming up. Can I have the next slide, please? So, in a nutshell, the SD tool analyzes nationally appropriate improvements, or NAIs, which are basically the type of intervention that countries are going to be doing to reduce greenhouse gas emissions. We calculate classification of 5 different types of domains of the types of SD benefits: environment, social, economic, institution, and other things related to development and growth. Each domain is broken into indicators, which are focus categories, and each indicator is broken into several different parameters, which is specifically what's measured. So as an example, if, for example, you're interested in air quality, the domain here would be the environmental domain. Air quality improvements would be the indicator, and the parameters you could measure could be kilotons of sulfur oxide emissions. So I'll just say generally before moving on that there are a couple clear recommendations for this type of system that's being put in. The parameters you select, for example, job creation, should be able to clearly point to your intervention. If you're going to be, saying that the NAI that you're putting in place is going to create 1,000 jobs, it's important that it's really clear, drawing a clear straight line to what you're doing. So you can't say, oh, it's also partially being developed by another project. It's also critical to use existing systems, institutions, local expertise, data systems that are already in place. It's important to not reinvent the wheel, use what's already in place, because these types of systems are very expensive and time-consuming to put in place. And from personal experience, the CDM through the Kyoto Protocol, NAMA development, it can really require a lot of time and effort to put them in place. So it's important to maximize existing resources where they are. Next slide, please. So that was the discussion on what is a Sustainable Development Tool, and now I will show it by using an application that we used in Sri Lanka to kind of show how it's used in practice. So in Sri Lanka, they developed a NAMA to kind of support their transport system. And in a nutshell, a NAMA is a voluntary non-binding instrument that reduces greenhouse gas emissions and also contributes to development and socioeconomic goals. And it also has the primary goal of trying to raise international funding in many instances. Even though there aren't many potential sources of NAMA funding yet, the NAMA facility is a main one. NAMAs are often used as kind of like a launching point to develop, or pre-feasibility phase to develop GEF projects or GCF projects. So just to highlight this, the Sri Lanka Transport NAMA. Transport is really one of the backbones of economic growth for the country. There is an existing policy framework that really emphasizes the importance of maximizing the use of public buses and railways. I think 41% of greenhouse gas emissions in the energy sector is related to transport, and there is a lot of political will to push improvements to the transport system, as it's highlighted in the INDC. Next slide, please. There are just a couple more statistics for the NAMA before I show the use of the tool. Specifically, it will involve implementation of 100 electric buses in Colombo. Also be installing charging stations, capacity building, and promotion and outreach is going to be a big factor. As it is a NAMA, it's very different from the CDM types of projects in that it's very important to have governmental buy-in. So this project was very important that we had extensive ministerial participation, and it results in around 3,700 tons of CO2 equivalent emission reductions per year. So it's very promising. And next slide, please. So I'm going to now show graphically how to use the SD tool, basically how this NAMA uses the SD tool to select SD indicators. And personally, I think this is a very useful methodology. It doesn't do the analysis for you, but it takes countries through the steps of what's needed to do a stock taking of your existing systems. It explains the types of data needed and how to use it. It emphasizes the links to Sustainable Development Goals. And finally, it really presents the data in a fashion that is useful and familiar to the UNFCCC in terms of the CDM projects and the NAMA facility in terms of NAMAs. These were basically used as inspirations on how to develop this tool. So this is kind of one of the first it's an Excel-based model. This is one of the first discussions of it. For Sri Lanka NAMA, one of the economic indicators is job creation. So you'll see in the bottom row of the spreadsheet, it highlights the SDG goal that's referred here. It says that the identified impacts are creation of skilled jobs, and it requests a detailed explanation on why this was chosen as opposed to other types of indicators. Next slide, please. This is, I think here we're talking about SDG goal 8, in target number 8.3, which it specifies decent job creation. Next slide. Thank you. This kind of takes it to the next step where it says, okay, well, this is the domain parameter indicator selected. How are we going to measure its progress towards success? So as an example here, under the economic indicator section, I'm staying with the example of job creation. Here, number of jobs would be the parameter divided based on gender and permanent versus temporary. The measurement value would be the number of jobs created. Baseline value, you currently assume there are 0 jobs associated with electric buses. The target value would be, for example, 100. And then in the next column, it says intervention value monitored. Here you would kind of track where you're at, how many jobs have been created as you go. And in a very simple calculation, it determines in the rightmost columns how successful it has been as compared to what the original target was. Next slide, please. Thank you. So these next two web pages kind of frame what are the sampling methodology that is determined to be used. This again is in line with the CDM, the NAMA facility requirements, and it basically shows what you're going to collect data on, who's going to be doing it, what's going to be the frequency, who's doing the improving, and who's conducting QA, QC on it. And in the lower right-hand corner, it mentions what a typical monitoring sheet could look like. And I only have like a minute left. If you can go to the next slide really quick, I'll say in addition to the SD tool, UNDP also has other tools. If you're interested in any of them, please let me know. I'll be glad to get you in contact with the project managers in these groups. Basically what they do in a nutshell is the first two analyze climate expenditures in the public and private sector. I'll highlight the MAPS project. What that is it determines SDG, or Sustainable Development Goal readiness, and identifies entry points to be used in policy assessment. And the last one, the number 5, I think is very interesting. It's called DRE. And what it does is conducts a modeling analysis to try to determine how effective a policy or a project would be in de-risking investment opportunities in energy. So I guess that's it. If you can go to the next slide, it's really been a pleasure. I've included links to the projects which I referred to. The first one is the BRT NAMA, and then the LECB project. So thank you very much. If you would like more one-on-one explanation on how to use these projects or to use the systems, please let me know. So thank you very much.
Thank you, James. Perfect timing as well. So we do already have a couple of questions. What I might just do is have a look at the questions that we've received and maybe direct some towards our presenters directly. So there is a question from a participant about the iJedi model, whether it incorporates existing policies of the states or of the country. Maybe Francisco, you could say something about that.
Yes. Well, no, the model does not include any policies. It will be up to the analysts to transform the policies into something that JEDI would understand. For example, when we model this example of the offshore wind development in the U.S., we try to find what policies will drive the development of offshore wind, and then use those as something that will modify the inputs as we go from one year to the other.
Okay, thanks for that. I also have a question here that would be directed more to James about how participatory the processes are in using this tool that UNDP has developed. So what in terms of maybe stakeholder engagement is being done to really collect and use the data that you use in the tool?
No, that's a good question, especially as compared to other carbon asset type projects like the CDM. NAMAs and NDCs are extremely heavily reliant on stakeholder engagement. Their goal is to really sector-wide stimulate markets. So you really want a lot of feedback at an early stage from the private sector that's critical. And the whole process of NAMA or NDC is nationally country-driven. So if you don't have extensive feedback at all stages, really, like from the people who are actually collecting data for the individual greenhouse gas data, all the way up to permanent secretaries at relevant ministries, there needs to be a lot of governmental support, because otherwise it runs the risk of this being a very theoretical target that isn't realistic to be implemented on the ground. It's really going to, it's kind of a cliche, but you really need a champion to stick with this and knock on doors and make sure this is a priority for policymakers.
Great, thanks for that, James. I have a few more questions coming in. There's one from Anna about the role that gender equality plays in these models. I suppose this is a question that goes toward what do you do with sort of cross-sectoral issues and indicators that go across all of these different domains. So she asks, how do both of the tools that you have presented capture job generation or other impacts from a gender perspective? So is it maybe possible to capture these results in a sex disaggregated manner? Maybe James, you first, and then Francisco, if you'd like to add something.
Yeah, sure. Well, we have flexibility, basically what in the way countries are set up for what priorities are. As you know, gender equality is one of the SDG goals, so it is. It can be very heavily emphasized that when you're determining job creation, you want to specify the specific support it's giving to men and to women, so you can highlight this. We did work in Bhutan, for example, where happiness index was the priority focus. So everything that we did in terms of developing policies and trying to prioritize the types of projects in their pipeline were related to this very specific thing. In Indonesia, the green economy was a priority. So we were not focusing on GDP, we were focusing more on green jobs and GDP for the poor. So these were specially made variables that were used to determine which policies would better inform what the specific country goals are. So I hope that answered your question.
Francisco, if there's anything you'd like to add on that question, please go ahead. Otherwise, we can also move on.
Sure. Yeah, it's a really good question. Not out of the box, the tool does not go to that level when it estimates job creation, but we've seen that the tool, like I said, for example, CFE, the utility in Mexico, they included, the tool is based in Excel, so it's very easy to modify, and they included a link to also to link the results to the Human Development Index. So the tool can be modified to track more gender-specific results, but not out of the box, not the design that we have on our website.
Okay, thanks for that. One question that has also been asked about the iJedi tool on a sort of more technical level, whether it is possible to disaggregate jobs or value added along specific value chains. So if you look at maybe solar water heaters or biogas, energy and renovation in buildings and so forth, whether it is possible to specify local parameters and really look at the entire sort of value chain.
Yeah, so at the, sorry, I guess there are two answers. For the international version, we try to simplify the interface. For the standard models, the results are a little more disaggregated. When we typically do that job of trying to disaggregate, but that's done behind the interface with the user to try to map direct impacts to specific sectors within the economy. But the quick answer is that no, you cannot see that level of disaggregation at the result level for the international version.
But would it, for instance, be possible to show parameters like jobs per megawatt of energy created through a specific system, or so to disaggregate to cross different parameters like that? I think that was part of the question, if I understood it correctly.
Yeah, so you can link number of jobs created, for example, to a specific project of a certain size. If that is the question, and then you can have aggregated numbers for development in a whole area. Like we did that with the offshore wind example, we have different projects aggregated together, and we express the aggregated results, but you can also have project by project results.
Great. Now there's another question here that looks more at sort of the subnational level. So how these tools can maybe also be applied to boundaries of local governments or maybe municipalities or the urban level and specific projects and policies. Maybe James, you can say something, because the SD tool in that way is also relatively flexible from what I know, correct?
Yeah, of course. I would say that the whole point of the SD tool and, for example, NAMAs are really to develop systems and projects and programs that are nationwide. So it's critical to make these things implementable on the ground in the subnational level. It really doesn't. It has no effect on the program because you're going to be entering many data points to kind of fill in the spreadsheet model, and it's going to have to involve data collected on the ground by specific public utilities. So it's actually a critical element to make this as realistic and case sensitive on the ground as possible, to give you a clear picture on what works in certain areas and what does not.
Great. Maybe to add to that and give a little bit of a clarification, we've now looked at economic impacts from different levels. So I started maybe more from a macroeconomic view, and these tools also operate at different levels. So they might look at a specific region or look at an entire country, or like the SD tool can look at a specific action like a NAMA. But maybe would it also be possible to look at the effects that a policy could have, or is that maybe too vague for the SD tool, James?
No, it's extremely relevant. It's more. It can be more of a challenge depending on what you're talking about. But for example, if you're trying to institute a feed-in tariff, to make these types of programs and policies politically palatable, it's critical to have clear to encourage buy-in from key government officials, and they're not going to really, risk reputation and credibility and all personal. I'm sorry, I'm not explaining this well. But basically, political partners are going to be most interested if the activity that you're doing involves benefits that they can benefit from. So their constituents are creating jobs, for example. So I kind of drift. Could you repeat the question one more time, please?
Basically, I was just asking about the level that you can look at. So it sounds to me you can look at a NAMA, which is can be a very specific action like building a BRT system, but it could also be just a measure to reduce a policy maybe. So would the tool also be able to, could you apply to just a policy in general, or does it look more at sort of the action level?
No, thank you for the clarification. It very much does both, and I was just saying that there should be actionable measures for policies as well. There have to be, really, in order to ensure you have political buy-in. For example, if you're putting in place a feed-in tariff, it's a system designed to kind of stimulate growth in, for example, a renewable energy market. So there will be measurable indicators that you will be interested in showing that the project is a success. So I would say, in general, you will be able to find real data based on activities on the ground, even if it's a more theoretical policy.
Great, thanks. One more question very quickly, because we did start a bit later. Francisco, you mentioned that the iJedi tool also looks at the Philippines. Is there anything that you can tell us there on what economic impact assessment might look like in the Philippines?
Yeah, so for the 5 countries, the advantage is that we already have installation costs and the multiplier matrices, which represent the economy of a region. So what you can do for any of these countries, the advantage is that you can use it, download it, and start using it as long as you know the size, the capacity that you want to analyze. It's very easy to just get results within minutes. And the results are the number of jobs created by these projects. These are, by the way, gross numbers. So it doesn't look at if you displace other type of generation. Would that new development cost or eliminate other jobs, and that's not something our tool does. But it shows you the gross number of jobs created, the total income that all those jobs will generate for the workers. So if you divide income over number of jobs, you can get the average salary for the workers, and also the contribution to the national GDP in the case of this type of national analysis, and finally the total economic output. And one thing I want to say related to the previous question is that the model can be modified to work at any level, basically, as long as you have multiplier matrices. Again, the example of the CFE, which is really good, they did a great job, and they modify the model so that it works at the municipal level and at the state level and at the national level in Mexico.
Thank you. Now I think we've reached the end of our webinar. There were still a couple of open questions, but please do have a look at the ALP website, which you can find if you also go through the LEDSGP website, ledsgp.org. You can also find the benefits website there, and we will publish the presentations and also the recordings there, and you can find the contact information of all presenters and myself as well if you have any more questions. So I think what we've learned today is that there are several different tools and approaches out there to assess economic impacts, and that this can be vital also to just engage stakeholders and to drive development towards more low emission and green pathways. If you'd like to learn more about these tools and approaches and others, please visit our websites, and we also invite you to engage in our regional and global meetings, which always take place annually, and you can always reach out to all working groups and the regional platforms of the LEDS-GP for technical assistance and with very specific questions and requests for trainings as well. Thank you very much. I'd like to thank the presenters and also ICLE for organizing the webinar, and I wish all of you a pleasant evening or rest of the day depending on where you are in the world. Thank you.